All right, Bailey and I are back for our take 4 of this video. As it turns out, Bailey, sit down. And so you'll remember that when we left off, we were talking about different types of chemical reactions. And we started with synthesis reactions. You guys had a quiz on this, did a great job. And so you'll remember that in a synthesis reaction, we start with 2 or more reactants, and they join together to make only one product. A good example of this, something we did in lab, is when we took a piece of solid magnesium. Let's see if we can move this up. A piece of solid magnesium, and we burned it. And when we burned it, it combined with the oxygen in the air to make a solid white kind of ashy substance, and that was magnesium oxide. Just go back and balance it. So you should be able to recognize a synthesis reaction when you see it. We then looked at decomposition reactions. Decomposition reactions are the complete reverse of a synthesis reaction. That is, we're starting with just one reactant, and it breaks down into 2 or more simpler substances. You did a worksheet on that. I have posted the answers to Google Classroom, I guess it was last week or so. Hopefully you had a chance to look at those. Good example of a decomposition reaction, one that we in fact did in lab. Look at this. This should be familiar to those of you in period 4. Look at that S. I think we know who this one belongs to. Anyway, what I wanted to show you is that we took one reactant, that is the baking soda, we heated it up, and it broke down into, this case, 3 simpler substances. So a good example of a decomposition reaction. As we continue, the next type, here it is, just showing you the difference between synthesis and decomposition reactions. Again, showing you the reverse. Synthesis is the reverse of decomposition. Anyway, our third type of reaction is called a single replacement. Sometimes it's called a single displacement reaction. And very often you'll see an analogy like this, where we have one guy here by himself. We've got a couple dancing. This guy with the red hair is tapping this guy on the shoulder, and the products, another single element, so to speak, and another compound. So we see the general reaction A plus BX yields B plus AX. And here's what's happening in a single replacement reaction, right? We have one element and one compound. So kind of like the single guy versus the couple dancing, if you will. Notice that it says that these reactions happen in solution. That is, we have to have one substance, that is the compound, that's dissolved. And so we can take this single element, this compound, the single element replaces the B, the second part of this compound. And so we end up with a new compound and an element. I've shown it this way as well. Sometimes the element that's being replaced is actually the second one. So notice this free element here might replace the Y, right? So now the Y is by itself and the X took its place. Now that might seem kind of confusing when it's just these letters. So let's look at some actual examples of things you've done in lab previously and see how those are single replacement reactions. Back in the beginning of the year, you did this lab where what you had was a piece of aluminum foil. I'll just put it as S for solid. You placed it in a solution of copper nitrate and you let it sit. And as you let it sit, 2 things happened. That blue color in the copper nitrate disappeared, right? It became clear. The other thing, very obviously, that happened is we went from this shiny aluminum over here to this red solid that developed. So what is that? Well, that red stuff is copper. The aluminum came in and took the copper's place. So we ended up with solid copper. Move this over so I'm not covering it. We ended up with solid copper, and turns out the aluminum took copper's place, so aluminum now became partnered up with the nitrate. Then this equation is not balanced, and it's not really the focus of this video right now, but just wanting to show you again, we are starting with these different phases: solid aluminum, copper nitrate, in solution. Aluminum took copper's place, and now the copper is here by itself. So that's one example. Another example of a single replacement reaction that you have seen in lab, this was a little bit more dramatic, I guess you'd say. Back in the beginning of the year, I took a piece of sodium, and then I also used a piece of potassium. So it was solid potassium, which is a kind of a gray metal, and I put it in water. And so let's call the water HOH instead of H2O. It's going to be easier to see this single replacement reaction. So took that solid piece of potassium, we threw it in water, and we see this really pretty exciting reaction. It started fizzing, and then it started kind of popping, and then we started to see flames. And in fact, I had put a color indicator in here, and it turned purple as well. Why? Well, what took place here, the potassium took hydrogen's place. So now the potassium is going to be partnered with the hydroxide, so it's potassium hydroxide, and this hydrogen is now by itself, and you know that hydrogen is diatomic, so I wrote it that way. And what you just learned recently in lab is that hydrogen is flammable, right? When you did it small scale in lab, it made a pop. Well, much larger amounts of hydrogen it's flammable. So when it catches on fire, we saw a lot of flames being produced and a lot of heat. So just be able to recognize a single replacement reaction, single element plus a compound, and then our products are once again a single element and another compound. I'm not going to be asking you to predict any products for single replacement reactions, just be able to recognize them. And finally, the fourth type of reaction to be aware of are double replacement, sometimes called a double displacement reaction, where we start with two reactants, or in this case of the analogy, we've got two couples dancing, and then they switch partners. So this guy here in the green was dancing with this woman in the red, and now they've switched partners. So guy in green is dancing with the girl in yellow, and the girl in red is with the guy in blue. So they're just switching partners. So if we want to look at it in terms of, more technical terms, here's your definition. The cations of two compounds replace each other in solution. So again, we have to have these two ionic compounds have to be dissolved in order for the reaction to take place. We're going to see tomorrow that typically one of these products will be a precipitate, but we won't worry about that now. So what's happening here? The A and the B are switching places. A was with X, now it's with Y. B was with Y, now it's with X. So again, sometimes I think it's a little bit easier to see it with these kind of two couples dancing. And so keep in mind, it's the cations of the compounds that are switching. The first part of each compound just switch places. They don't partner up together. The A and the B don't partner. They switch places. Let me see if I can get you to see a YouTube video of a double replacement reaction. Let's see if this is going to work for you.
In the double displacement reaction of silver nitrate and sodium chloride, we have a solution of silver nitrate, which is colorless. We'll add a solution of sodium chloride, which is also colorless. When the sodium chloride solution is added to the silver nitrate solution, a white precipitate, insoluble silver chloride, is formed.
Okay, perfect. So you can see that we have that double replacement reaction. We had the two compounds, silver nitrate and sodium chloride, and then we ended up with two new products. So let's see if I can get back to this screen and fill that in for you. So we had AgNO3 in solution, right, plus NaCl in solution. They reacted. the silver and the Na switch places. So now Na is with the NO3 and the Ag is with the Cl. What was nice about this one is all the charges are the same, so we don't have to worry too much about that crisscross rule. What we will worry about starting tomorrow is you will need to predict the products. You will still need to know how to come up with the correct formulas. And for tomorrow, we'll figure out how do you know that the AgCl is the one that's the precipitate as compared to the sodium nitrate. But that's for tomorrow. You'll see on Google Classroom, I've posted a worksheet that helps you identify the 4 types of chemical reactions. If you need help, 2 things. 1, go back to the video and see if you can find the answer to your question, or I'm certainly free most of the day, and you can just send me an email or do something through Google Classroom, send me a message that way. All right, guys, I will talk to you tomorrow. And say goodbye, Bailey? Nope. All right. Bye, guys.